Let us use the direct comparison test to determine whether this series converges or not. First, I want you to observe that n squared plus 7 is greater than n squared, right? Because I added 7, there is no 7 here, so obviously n squared plus 7 is greater than n squared. And when we take the reciprocal, 1 over n squared plus 7 will be less than 1 over n squared, okay? Why? Because the denominator here is large, and here the denominator is small. And always when you increase the denominator, the fraction becomes smaller and smaller. And so the less than inequality here is true. Now what we're going to do here, we are going to multiply or throughout by the root of n. So in the numerator, root n, and maintain the denominator. So this will still be less than the square root of n divided by n squared. Okay, now what we have on the left side here is what is the nth term. Okay, now what we're going to do, we're going to rewrite this is n, the square is just half divided by, the square root is a half divided by n squared. And because the bases are the same, we can combine the bases are the same, we can combine the powers. So this is just n, then 1 over 2 minus 2, and this is just 2 over 2, which is negative, right? So n negative 3 over 2. And we can write this as 1 over n to the power 3 over 2. Okay, so we observe that. So our observation here is that the square root of n over n squared plus 7 is less than what we just found here, 1 over n 3 over 2. Now let us observe one thing. Remember this series n1 to infinity of 1 over n 3 over 2 is a p series with p which is 3 over 2, and this p is greater than 1, meaning that this series converges. Okay, and so because the nth term of this series is less than the nth term of a series which is converging, then we conclude that by the direct comparison test, our series in question also converges.